Hi, everybody. I'm Tanya Pahuja, and I'm a technical account manager here at AWS, and I'm based out of Delhi, India. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower cost, and provides you with the best practices and design considerations. Joining me today is Kunal from the AWS Professional Services team. Kunal, can you give us a quick introduction, please?
Thanks, Tanya. Sorry. Hey, good morning, all. My name is Kunal Gautam, working as a senior big data consultant for Amazon Professional Services. Been in the domain for 13 plus years and have worked across 30 plus enterprises across the globe to bring in the cultural and technological changes required to have a positive business impact, leveraging AWS big data services and machine learning and AI. Over to you, Tanya.
Thank you, Kunal, for your introduction. So, today we will be covering around the recapping of the reInvent launches, basically in the big data and analytics domain. But before we get into the details, a quick note to the attendees online. Use the chat window on the right hand side of your screen to let us know where you are joining us from today, and also share your thoughts and questions throughout the episode. We really look forward to hearing from you. We will also provide a link to our survey. So if you would like to let us know how we did during the show, and if there are any questions and feedback, just leave your feedback there. With that, Kunal, can you help us walk us through what all that we would be covering up today?
Thanks, Tanya. Let's go ahead with the agenda. So we'll start with Amazon DataZone, AWS Clean Rooms, AWS Glue, Amazon Redshift, Amazon Aurora zero-ETL, Amazon Athena for Apache Spark, and Amazon QuickSight for Paginated reports. So even before we start and go for a deep dive, let's look at the end-to-end data journey. So if you look at any data product or any data pipeline, so overall it's divided into 4 stages. The first stage being the data ingestion, the second stage being the data storage, the third one, data transformation, and the last one, data consumption. So if you look at ingestion, your data assets could be on premises, it could be on AWS, it could be scattered across your databases, your SaaS application, your third-party data, media data, streaming data, and they have to be ingested. All that data goes and gets streamed or gets copied over to Amazon S3. So Amazon S3 allows you to store data at petabyte scales in a safe and secure manner. And that's what we pretty much call a data lake. So once you have your data on a data lake, you can have your data warehouse solutions like Redshift, which can allow you to query your data. You can also have NoSQL stores like DynamoDB. You can have databases like Aurora, RDS, which can also help you to store data and have analytical results on top of it. For transformation at a distributed scale, we use services like AWS Glue, Amazon EMR to process your data at scale. And last but not the least, once you have your data, we can leverage Amazon QuickSight to go ahead and consume this data. So now if you correlate between the agenda and the data journey, what we can see is the Amazon Data Zone, AWS Glue Clean Rooms, they lie at the center of this diagram. Redshift, Athena, Glue, they all are used for data processing and ad hoc query. Last but not the least, QuickSight is being leveraged for the data consumption part. Let's go ahead and do a deep dive into each of these new services and all the cool and amazing features that has been announced. Let's get started with Amazon Data Zone. So folks, here is a problem statement. There's an enterprise, and in the enterprise, you have manufacturing units all the way from Berlin, New York, Tokyo, and you have the IT being served from Bangalore, and the head offices are spread across, let's say, Tel Aviv. Is it possible that we can go ahead and figure out what are my data assets that are spread across the different geos? How is it possible that I can go ahead and discover this data seamlessly? So let's say somebody at a business level sitting in New York wants to figure out, hey, in my Tokyo plant, what is the data that's available there? Can I have access to that data? What are the governance rule? Is it possible that I set a governance rule and the governance rule will be applied to the data across all the manufacturing plants out there? Last but not the least, how easy is it to use tools and services to process my data and get insights from that so that I can make data driven decisions as fast as possible? If one tries to solve this problem, it will take months and years altogether to build this solution. So forget about getting all the beautiful insights from this data or the amazing insights from this data. Just to build this platform will take a huge amount of time. And that's where Amazon DataZone comes into being. So Amazon DataZone helps you to search, share, discover data at scale across organizational boundaries. It allows you to collaborate on data projects through a unified data analytical portal. There are two main tenants. One is the producer and one is the consumer. So all it is trying to do is it is reducing the distance between them. And when I say distance, it could be in terms of tools, it could be in terms of services, it could be in terms of the geographical distribution between them. How easy is it that all the different stakeholders for the data, they get all together and they are able to share their data, they're able to leverage the power of their data irrespective of where they are located on this planet. So that's what the Amazon data portal provides. What it allows you to do is your data assets can be sitting on premises. It can be on AWS or it can be any other SaaS application. It allows you to browse, understand, connect, search, and collaborate these data assets across the different stakeholders by leveraging the different AWS tools out there to process your data and gain insight. So holistically, if you look at it, it is providing you three important features. First is it provides you a 360-degree view of all your trusted business data spread across the different geos and AWS regions. Secondly, it provides you the ability to access your data in accordance to the compliance and security regulations of your organization. Because different enterprises, depending upon what kind of vertical they are working around, the regulations requirements are different. So it is quite possible that you have a central governance layer, and this governance layer ensures that all your data layers or data assets are adhere to that. Each and every stakeholder has to adhere to this requirement. Last but not the least, because now you are able to democratize your data sitting across the different geolocations, you increase the productivity by inviting the different stakeholders or members on your data projects, by not only providing them the data access, but also providing them data governance and the right tooling to go ahead and gather access to your data. So let's look at the two most important tenets of your data zone. The first being the producer and the second being the consumer. Because for the data, somebody is producing it and somebody wants to consume that. So let's look at what a publisher can do in the data zone. So a publisher is the one who is generating the data or producing the data. They are able to decide where will I produce my data, who should be able to access my data, what kind of taxonomy I can fix on my data. I can tag my data saying that, hey, this column is a PII, this column belongs to this specific department. Last but not the least, if I am the producer, I would also love to see who are able to access my data. I should get a log somewhere or a metric saying that these are the folks who are leveraging my data, so that I can also understand Is my data really useful? Are people really able to, first of all, figure out my data? And secondly, is this data useful? Is it repetitive? Or is it only something that only one business unit is using? Or is it something it's so important, maybe 10 business units are using it across the globe? From the subscriber part, first of all, the subscriber gets the ability to search your data because the data has been cataloged, not only leveraging technical taxonomy, but also business taxonomy. So I'm able to search the data. Once I'm able to search the data, am I able to send a request? Because the owners, or let's say the ownership of the data lies with the producer. So can I go ahead and access the data, request for this data? Once the producer of the data provides me the request, I get the subscription over the data and I go ahead and start leveraging it. And it doesn't matter. And it all happens through this single portal, this amazing single portal that's out there. The most important feature which allows you to make your data discoverable, that allows the subscribers of the data to easily go and figure out who is the owner, what kind of data lies, what kind of data asset this belongs to. It is all coming up because DataZone not only provides the ability, just like AWS Glue data catalog, that not only technical taxonomy is there, that this is a table, this is having columns, and this is the description of a column. Rather, it also provides you the ability to go ahead and create organizational domain. So the organization domain pretty much correlate to your org hierarchy. So in an org, there'll be different business unit, and that's what you see in the catalog structure. You have a corporate, and then you have different business units there, R&D, manufacturing, procurement. You have a metadata template. So each business unit can own their data asset, and they can go ahead and create a metadata template, which allows them to create, hey, how am I gonna go and and create a business taxonomy on top of my data? So I already have a technical taxonomy. Can I create a business taxonomy? Once I'm able to create the metadata, this asset is published. And in the portal, it pretty much looks like a marketplace that you have all the data from the different business unit who owns that. You can go search, subscribe to it, and start leveraging it. So if you look at Amazon DataZone holistically in terms of big data, it provides you the ability to create geo-distributed data lakes with the ability to search, catalog your data, and have a central governance to which all the stakeholders, data assets, and tools comply. With this, we move on to AWS Clean Rooms. So let's look at another problem statement. You have a media ad tech company. You have multiple stakeholders. You will have folks from customer care. You will have campaign managers. You will have different ad agencies. You will have partners who are going to enrich your data. All this data will come to a central place. And the challenge is each and every one wants to share a piece of their data with the other stakeholder. Let's say, for example, the ad agency folks wants the ad tech to use certain portions or certain columns of their data, not all of their data. Similarly, the campaign managers would like to see certain aspects of the ad tech data. How easy is it to build such a system? So if you look at this problem, if you go ahead and figure out what is the best mechanism, soon you will realize the only way out there would be to maintain multiple copies of the data by the different stakeholder, which also implies that every time a refresh happens, all those copies have to be refreshed. Secondly, if you go ahead building this system, this is a pretty much complicated task and it takes months of development time. Last but not the least, the privacy control will require quite a complicated mechanism to implement that. So to solve this problem, AWS has come up with AWS Clean Rooms. So AWS Clean Rooms helps customer and their partners to more easily and securely match, analyze, and collaborate on their combined data sets without the need for any sharing or revealing their underlying data. So the benefits of that, the first benefit is there is no data movement at all. You just create a single copy and you are allowed to create rules on who can consume this data, what portion of this data will be used for analysis, what portion of this data will be used by consumption by the different partners. All you can do is go to a clean room, you add participants who can collaborate on this single data copy. There is no need at all to reveal your underlying data, and that is done by using a construct known as associated tables. You are able to protect your underlying data with a broad set of configuration access pattern controls. So these are much more fine grained control, which can say that which column which participant can see. So although you have a single copy, still you can go ahead and you can define the control for each and every participant. And you are able to run queries adhering to these rules. So in the clean rooms, we have the concept of an analytical rules and output constraint, which allows what participant can see what, and last but not the least, for analysis, what will be the output, like what part of the output should be constrained, it should be not visible, or you are not allowed to access that. These kind of definitions are stored there. So with this, I take a pause. Hey Tanya, do you have any questions?
Thank you, Kunal, for taking us over, these services and giving us a quick recap. Just one question on behalf of the audience. Can you name some domains that will actually benefit directly from these services that you've just talked about?
Right. So as I mentioned, both for DataZone as well as the clean rooms, media ad tech is one of the biggest player. Autonomous driving, ADAS systems. So there are a lot of companies working in this domain. They will benefit from this amazingly, given that for ingestion, storage, consumption, there are different partners that they work along with. Given that the data is in like petabytes of scale, you do ingestion at terabyte scales there. So that's another domain that will immensely benefit. Another is the fintech, because the same problem statement, you are getting data from multiple sources, enriching that, and then finally you use in the fintech to figure out the propensity of a user doing something. So that's another domain. So if I look at it, any domain which is involving partners, who is geo distributed, who wants to share their data, ensuring that the governance rules are applied, it applies to pretty much all those domains out there. And I have just called out few of them.
Got it. Thank you, Kunal. I hope that answers the question from one of our audience. It was from Jitjab06. Thanks, Kunal, for answering on that. Over to you, and I think we'll hear you out more talking about AWS Glue in the upcoming slides. Thank you.
Thanks, Tanya. So let's moving on ahead, folks. Let's focus on AWS Glue, which is the transformation layer. If you remember the first diagram, the transformation layer in the between, wherein your data have been ingested onto S3, and you want to process that data. That's where AWS Glue comes into being. So what is AWS Glue? AWS Glue is a serverless data integration service that makes it easier to discover, prepare, move, and integrate data for analytics and machine learning purposes. Glue can be used both for ETL, ELT, streaming, and batch processing. Glue not only provides the ability to process, but you can also build your pipelines. You can go ahead and schedule them based on your input pattern or your requirement. So Glue as a whole provides you all this ability inside a single portal. So Glue came out with the Glue 4.0 version that came out with. It has started supporting Spark version 3.3.0 as compared to 3.1.0, and Python 3.10 is also being supported now. So it has become much more performant. You have more push-down predicates that has been enabled out there. The most important aspect that you have your data and you want to change just a part of the record. Let's say you are having 1 terabytes of data and you wanted to change like 10 records out of that. So previously we had to read this 1 terabyte of data, make the one couple of record changes, and then save back this 1 terabyte of data once again. So Glue 4.0 has introduced the formats of Apache Hudi, Apache Iceberg, and Delta Lake formats, which are now native to AWS Glue. So you just enable a parameter and you are ready to use any of these formats, which allows for cost as well as job performance optimization. Glue 4.0 also enables you to process your data at scale by leveraging the Cloud Shuffle storage plugin on S3. Because Glue 3.0 and prior, they were pretty much limited by the instance storage type for all the shuffle to be taken care of. In case your shuffle was increasing more than that, either the job used to fail or you had to scale that out, like you had to horizontally scale that out. So Glue 4.0 allows you to leverage S3 to handle your Spark shuffling. It has also upgraded connectors for RDS, MySQL, and SQL Server to ensure that jobs are much more performant and efficient. Last but not the least, the Glue 4.0, as you write your PySpark script, it looks at those scripts, it dynamically optimizes your query to make your PySpark much more performant. Glue has another important service. It has come up with another engine known as AWS Glue for Ray, which allows you to scale your Python workload. Just like, because this is another engine type, so all the cool features of Glue being serverless, you not have to taking care of the infra part, auto scaling, it's all taken care automatically. It is extremely cost effective because it goes by the pay as you go billing model. So moving on from our ETL onto our data warehouse part, which is Redshift. So let's look at Redshift. Before, if you wanted to get data out of Redshift, it was quite a cumbersome process. So Redshift, Amazon Redshift integration for Apache Spark has come up, which opens up the Redshift data warehouse solution for a broader set of AWS analytics and machine learning use cases. You can pretty much write your PySpark jobs either in Java, Scala, or Python and get access to the data which is sitting inside Redshift. The Redshift PySpark plugin has been built on existing open source connector and enhances its performance and security. And it is also 10x faster application performant. So this PySpark application, you can pretty much go ahead and you can write that either in EMR, Glue, or even in your Amazon SageMaker notebook. So you just go ahead, leverage the connectors, and bam, you are good to go by integrating any of these services to leverage, to get the data out of Redshift and mix and match, transform with the data sitting on S3 or DynamoDB or Aurora and get deeper analytical insight onto the data sitting on Redshift. The next important feature for Redshift is the streaming ingestion. So let's look at a problem statement before this service was announced. So you had real-time data streaming in from Amazon Kinesis or Amazon Streaming Managed Kafka. As this data was streaming in, you had to push the data onto a fire hose. Then it used to stage at S3. And then finally, a copy command was being used and the data was being copied onto Redshift on a staging table. And finally, the staging table was getting merged into the final table. You had to create this pipeline. This pipeline had to be maintained. Last but not the least, if there were errors, you had to really go ahead and figure out what's happening. If there were some errors, maybe have some missed out my data, you had to do this plumbing task manually to ensure that you are not losing your data. So Amazon Redshift streaming ingestion allows you to ingest hundreds of megabytes of data per second, which allows you to query your data in near real time. You can connect multiple Amazon Kinesis streams or Amazon managed streaming for Apache Kafka, that is MSK, and pull data directly to Amazon Redshift. So in this case, Amazon Redshift itself becomes the consumer. You don't have to stage your data anywhere because Amazon Redshift, and when I say Amazon Redshift, it also goes for the serverless part. Yeah, both the flavors of Amazon Redshift. So they themselves became the consumers. They are consuming data directly from your streaming solutions of Kinesis and Kafka, and allowing you to create materialized views. So as and when your data is getting pushed, your data is available in the fastest possible amount of time in Redshift, so that the downside consumers or the consumer of this data can start running analytical queries on top of it, gather data insight, and make data-driven business decisions. Moving on to one of the most important features, or let's say something that's really gonna change how people have been using their Aurora databases. Amazon Aurora zero ETL to Amazon Redshift. So let's look at a problem statement that initially in an organization, there were different business units. So there was a finance department, there was a manufacturing department, there was an HR department, there was a department to maintain metadata. I wanted to go ahead and ensure that there are no data silos. So what was the mechanism? The mechanism was get the data dumped out from all these Amazon Aurora instances, push it onto S3, create these ETL data pipelines, which will keep doing this activity. What it means is it goes ahead on a daily, minutely, or hourly frequency. You had to pull out data, push it onto S3, create a data lake, have a lake formation on top of it for the governance, and that's how you were able to break the data silos in your organization. But to build this, you really had to have a workforce of data engineers and data scientists to build your data pipelines, maintain them. And it was pretty much costly, as well as the job used to take time. The refresh rate was not like seconds or milliseconds, right? Because it's quite a time consuming process to write this ETL, as well as for the ETL to execute. What Amazon Aurora now supports is zero ETL integration with Amazon Redshift, which allows you to have a real-time analytics and machine learning use cases using Amazon Redshift on petabytes of transactional data. What it means is, as and when the transaction is happening, you go ahead and you can start leveraging this data to be processed, to be transformed, for the analytical queries to be run on Redshift. So as and when your data, transaction data, is coming up on Amazon Aurora, that data is copied onto Redshift. You don't have to build any ETL pipelines now, because this copy is completely seamless, and it's happening all under the hood. So all you have to worry about is, hey, I have 10 Aurora databases. I consolidate, or I just connect this 10 Aurora databases to my Amazon Redshift cluster. And in my Amazon Redshift cluster, I can go ahead and start running my analytical queries without maintaining any ETL pipelines to move the data from Aurora to Amazon Redshift. Let's look underneath what's happening under the hood. So first of all, Amazon Aurora has its own storage, and as and when the transactions are happening, the data is copied from Amazon Aurora storage to Redshift storage. Just keep in mind, we are not talking about 1:1 mapping. Rather, you can have multiple Aurora instances writing to the same Redshift instance. So you can consolidate Aurora. So this is pretty much thinking like of a data lake, without writing any ETL in between. The next beautiful feature is that Aurora, because it's a schema evolving solution, if the schema evolves, Redshift will also ensure that it understands this schema evolution and it is also available for the consumers of Redshift. And you can leverage all the cool features of Redshift, such as materialized views, data sharing, federated access to multiple data sources, and data lakes. So this combines the power of Aurora, gathering the data, and also enabling for the end users to go ahead and query this data, all by leveraging just a single click. Hey Tanya, do we have any questions till now?
Thanks, Kunal. I think there's one question that we have from one of the audience on the chat, hacker PBK, and I think this is one of the very frequent questions, right? Which we kind of see from the audience. What is the difference between Glue and Athena? So, would you like to answer that for the audience, please?
Right. So let me come up with an analogy, and that will help you to appreciate the fact why do we have different services. So when humans started counting, we started using abacus, right? Like we are very primitive, we started using abacus. Time progressed, and we went ahead creating semiconductors, and calculators came into being. Time progressed further, we had computers or desktop or laptops in our home, and we started using Excel. Time further progressed, and now we have data coming at petabyte scale, and we are able to still consume that data and figure out, hey, who is doing well in the elections, or what is trending on Twitter. Just look at the scale. Billions of events are coming, and you're still able to find the scale. So what changed in this hierarchy? The only thing that changed was how you are processing your data and at what speed you can process that. It means the underlying engine. The underlying engine for abacus was human brain. The underlying engine for calculator was the semiconductors. For Excel, it was the CPU power, right? And for this trends and everything, you have the big data processing system like Spark or Presto or MapReduce. So now coming to this question, even in the big data solution, the first engine that came into being was known as MapReduce. But MapReduce had certain problems, which was fixed and optimized. And then the engine that came was known as Thales. Then came Presto, and then came Spark. Spark and Presto came almost at the same time, but Spark being much more performant. So now coming back to Athena is based on Apache Presto. Spark ETL distributed processing, because Glue provides Apache Spark ETL and Python ETL, right? So I'm focusing on the Spark ETL part here. So Athena is completely based upon Presto. You cannot write code there. You can just have SQL, like you can just connect with Athena using SQL queries. So what it does is, anybody who has no understanding of programming can still go ahead, just go to this dashboard of Athena or the portal of Athena, look at their data, create tables on top of it, and using SQL, they can process their data and get insights to it. But let's say somebody who knows coding and they want to leverage the power of Apache Spark, which is much more performant as compared to Presto, right? They can go ahead, write code, interact with their data, and go ahead and process the data. Glue is like, from the service perspective, AWS Glue is more towards writing data pipelines. Athena is more towards doing ad hoc queries. You are not expected to write pipelines using Athena. Athena is just ensuring you're given a portal, you write SQL queries, you don't worry about the infra, like what's happening in the background, and still you're able to process. In Glue, you need to have some level of understanding how Spark works. You need to have some coding understanding how to code that, write the ETL pipeline, which are repetitive. So just to keep the answer very simple, Athena is more for ad hoc queries running on Presto. Glue is for running ETL pipelines, mostly taken care by data engineers, and you are able to run this pipeline again and again to keep processing your data. Hope that answers his question.
Thank you, Kunal. I think that was really an elaborative explanation onto what is the difference between Glue and Athena. So I think just to summarize, the key difference is Athena is primarily, which is used more on a tool for the analytics, while as Kunal explained, Glue is more of a transformation and a data movement tool. I hope that answers the question for our audience. And then moving to a next question that we have, Kunal, from one of the other audience that we have today with us on live. Are there any other services other than Glue that can be actually used for distributed data processing? Can you shed some light there as well?
Of course. So Glue is, as I mentioned, for the data transformation, you have multiple other services. Glue is one of them, and Glue is based on Apache Spark. We have another service known as Amazon EMR, Elastic MapReduce, which can pretty much do the same task. The only thing is the interface is different, and Amazon EMR is much more, let's say, complicated to handle, because you need to have a better level of understanding in order to operate it. In Glue, the infra part is completely invisible. You just focus on writing the script. You need to have some level of understanding, but you just need to write your script. You don't have to worry about what's happening in the background. How is the infra being spawned? How the infra is being taken, teared down? You don't have to worry about that. In case of Amazon EMR, EMR just before the reinvent, both the flavors has come out. So we have EMR cluster, wherein you have to have a very good understanding of the cluster. And the beauty of EMR is it allows you to write your code in any of the analytical engines. So what I mean by that is you can write your code in Spark, you can write your code in Presto, you can write your code in Flink, you can write your code in MapReduce. So all the analytical engines that we can think of, it's all part of a single package. And in EMR serverless, you don't have to worry about the infra. You just go ahead and you write your Hive jobs, or you go ahead and write your Spark jobs and submit it leveraging an API. The infra part is automatically taken care by AWS. So it's pretty much moving on the lines of Glue now, that you just worry about writing the business code that helps your business to grow and not to worry about the infra. So these two, like Amazon EMR and EMR serverless, is the closest one to Glue that you can think of.
Great. Thanks, Kunal. Again, I think that again was really a nice explanation. So I hope that answered the question for the audience. I think back to you to cover the next upcoming slides and the next launches that we have. Thank you.
Great. Thanks a lot, Tanya. So let's move ahead with Amazon Athena for Apache Spark. So folks, as you know, Amazon Athena was supporting Presto with a SQL interface. So you go ahead, you create a table on top of your data set, you use SQL, and you can run your ad hoc queries for doing any data sanity. You want to figure out what's happening within your data, unique user count, unique number of rows, all these operations you were able to do. And the beauty of that was Amazon Athena is completely serverless. So you never worried about the infra. You just went ahead, created a table, and started doing analytics on top of it. So let's go for a little bit of deep dive of what's Amazon Athena, like in a much more structured fashion, and then we'll stick onto what is Apache Spark, how is the feature of Apache Spark that's gonna ensure that more users will be leveraging this feature to process the data, because now it supports both Presto as well as Spark. So first of all, Amazon Athena, it allows you to run interactive analytics in under a second, because it's all serverless, to analyze petabytes of data. The Apache Spark feature that has come up, it's an interactive Spark application or notebook that starts instantaneously, runs faster, because Amazon has provided the Spark optimized runtime. So you write your code in the notebook, you don't have to worry about the infra. It looks at the code, optimizes it, and executes that on your behalf. It allows the user, because everything has been taken care of apart from the code that you have to write. So you can spend more time on the insights, on doing ensuring that the data-driven decisions can be made faster, and not managing the infra that's running in the background. The solution is completely serverless, fully managed, and you don't have to provision, maintain, or configure any resources while using this feature. Last but not the least, I would request everybody to start using it, because this is one of the super cool tools that you will leverage to do any kind of data sanity test, to do like any kind of ad hoc analysis, leveraging the power of Spark. So pretty much before, what used to happen was, you go ahead, you are building an application in Spark, you go back to Athena for your data science test. For example, I know that, hey, in my input I have 100 rows. In my output data set, I'm expecting 10 rows. And the ETL pipeline, you are leveraging EMR or Glue to do that. And then what happens? Hey, I want to see what my output is. Is my data correct or not? So I go to Amazon Athena, do an ad hoc analysis on my output data set, and figure out this is my expected output. And that's how you were able to close the loop, saying that my ETL has run fine and this is the expectation. The challenge here was, as a data engineer, I had to learn PySpark, I had to learn SQL, which is expected, but I'm just saying you had to switch. Now what's happening is, as a developer, if I just know Spark, I can run my ETL in Glue or EMR using PySpark, and same code I can just leverage in Athena to go ahead and do my ad hoc data science test or ad hoc queries. And Spark being much more efficient as compared to Presto, your queries will be running much more faster. You will be paying a lot less without the need to maintain or manage any infra. Right? So with this, we move on to QuickSight. So if you remember our first slide, the data journey, QuickSight comes at the very end, which is the business intelligence tool for the consumption. So QuickSight has come up with a very cool feature of paginated reports, which allows you to create, schedule, and share reports and data as a single fully managed cloud-based BI solution. So the reports that you get now, it is almost like a storyline. Why is that? Because you get it like a document through which you can paginate. You can create headers and footers. You can create line breaks. You can go ahead, create the different graphs, the widgets. You can add all that as part of your report. This report can be shared by thousands of users who can leverage it to take data-driven decisions as fast as possible. So you don't worry about you did not have to, again, this is a serverless solution. You need not worry about the infra. You need not worry about how the analytics has been done or how the transformation has been done. You just worry about just dragging and dropping, creating cool paginated reports, and sharing this report with the business owners and stakeholders to go ahead and make data-driven decisions with a single click on their laptop or desktop. So Tanya, that's all from today's session.
Thanks, Kunal. I think that was really, great insights by you into the launches and what all new things that has, come on the recent reinvent on the big data and analytics side. I think lot of info that we kind of discussed today. I do not see any questions from the audience further, so I think we are good for today. And I really appreciate you going through all the big launches and basically on the big data and analytics side. So I hope our audience have found them really helpful. With that, I think today we kind of already closed on recapping on the reInvent launches, basically on the big data and analytics side. So if there are any questions that you all have that we were not answered, that we were not able to answer today, you can post your questions on repost.aws, where one of our experts can provide you with an answer to your question, or probably your question could become a topic of one of our future shows. And if you have any feedback for us for any of the next shows, if you would like to hear us anything that you would like to, include as a part of the show, please check the chat box on the right hand side for a link to our survey. Or you can also email us at awssupportsyou@amazon.com. We would want to hear from you. Tell us what else you would like to see on these shows. And with that, I would also like to call out, please join us again in 2 weeks on January 25th at 10 a.m. IST, where our experts will also be going ahead and talking about AWS Health Aware ServiceNow integration. And I hope that that is going to be helpful as well. So again, thank you, Kunal, for joining us, and thanks to everybody who has joined us today. Really, really appreciate all your time. And thank you again. Happy cloud computing. See you next show. Thank you.
Thanks all. Amazing day ahead.